Solving systems by substitution. In this section, there are going to be 5 steps that are going to help you when solving systems of equations by using substitution. So here are the 5 steps. I want you to write all these steps down. Make sure you have this. The first step, you're going to solve for one variable in at least one of the equations if that's necessary. Once you solve for one variable, you're then going to substitute the resulting expression into the other expression, or into the other equation. Step 3, you're going to solve that equation to get the value of the first variable. Step 4, you then would substitute that first value into one of the original equations to solve. And then for step 5, once you solve to find your x and your y values, you're then going to write them as an ordered pair, x comma y, and check your work. So let's look at a few examples of how you would go through and solve these with these steps by using system of equations in substitution. So we have our first example here. It says solve the system by substitution. So we have y equals x plus 3 and y equals 2x plus 5. Notice both of these equations are equal to x, or equal to y, so I'm going to set these equal to one another. So I'm going to set it up as 2x plus 5 equals my x plus 3. And I set it up like this because we're now going to be able to solve for our variable x, and once we find x, we can substitute that value into one of these equations to help us find our y. So let's do this. Let's take our 5 and bring it over to the 3. So we're going to subtract 5 to each side. And we're going to take this x here and move it to the left side by subtracting x to each side. 2x minus x is going to give me x equals 3 minus 5 is going to give me negative 2. I've solved for x, so now I need to find my y by choosing one of these two equations, plugging in my negative 2 for x to find my y. I'll just look at my first equation here. So I have y equals x plus 3. We said we're going to substitute negative 2 in for x plus my 3. So y is going to equal negative 2 plus 3 is going to give me 1. So I've now found my x and my y values. So I'm going to write my ordered pair, negative 2, comma 1, my x, comma y. So we have a variable that is solved for, the y. We're going to substitute, so we substituted by getting them equal to each other. We're then going to solve and find our x, and once we find our x, we're going to substitute it into one of the equations to find my y, to get my ordered pair. So those were the steps involved. Our last step we have to check. By substituting x for y, negative 2 for x and 1 for y to make sure they are true situations. So I can look at my first one and we can have y, so it's 1 equals my x, negative 2 plus 3. Does negative 2 plus 3 give me 1? Yes, that is true. That works. Let's look at the next one. Y equals 2 times my x. X is negative 2 plus my 5. So we have negative 4 plus 5. Does that give me 1? Yes, so that is also true. So that's my check step there. Make sure you're showing your work. Make sure you find your ordered pairs. That's your final overall answer, but then you also have to check to make sure that the system of equations are true for the x and the y that you found. Our next example here, we have x equals 2y minus 5 and x plus 8y equals 16. Notice my first equation is equal to a variable, but my second equation is not. So we need to get this second equation, x plus 8y equal to 16, equal to a variable. Let's get it equal to x since my first equation is equal to x. So I have x plus 8y equals 16. So I want x to be all by itself, so I'm going to subtract 8y to both sides. So we have x equals, the way I'm going to set this up is going to be in the same format of this 2y minus 4, but I'll just put negative 8y plus 16. So I've solved for my variable. I have x equals 2y minus 4 and x equals negative 8y plus 16. Now what I can do is get these equations equal to one another. So I have 2y minus 4 equals negative 8y plus 16. So I'm going to be able to solve for my variable y. Once I solve for y, I can substitute that value into one of these equations to find my x. Let's add 8y to both sides. So I'll move the y's over to the left. I'll add 4 to each side. So I'm moving the numbers by themselves to the right. 2 plus 8 is going to give me 10y equals 16 plus 4 gives me 20. I solve for y by dividing 10 to each side. So y is going to equal 2. 20 divided by 10 is 2. I've now found y, so I can choose one of these equations to help me solve for x. So I can look at my original, my x equals 2y minus 4. So I have x equals 2 times y now is 2, minus 4. 2 times 2 is 4, minus 4. So my x is going to equal 0. Have I found my x and my y? I sure have. So I can now write my ordered pair, which is going to be 0, comma 2. That is my ordered pair. But I'm not done because I need to check by substituting in 0 for x and 2 for y to make sure that these equations are true with the ordered pair that I found. Excuse me. So looking at the first equation, x is 0 equals 2 times my y now is 2 minus 4. Does 2 times 2 times 2 is 4, minus 4, does that equal 0? Yes, that is true, so that works. This is my check step again. Let's look at the second equation. Let's plug in 0 for x, 0 plus 8 times my y is 2. Does that equal 16? Well, 8 times 2 is 16. That equals 16, that is true. So my ordered pair 0, comma 2 works. Going on to my third example here, it says solve the system by substitution. So what I'm going to do here is I'm going to set one of these equations equal to a variable. Let's choose our first equation. We have 2x plus y equals negative 4. I'm going to subtract 2x to each side. So what I have here is y equals, and I can write it in the y equals mx plus b form, which is negative 2x minus 4. So that's what my y equals. So since y equals that, I'm going to substitute this into my second equation to help me solve this. So I have x plus my y. What did we solve for y? That's negative 2x minus 4, which equals negative 7. Notice we have x's here. So we can solve for my x. We can combine like terms. X plus negative 2x gives me a negative x minus 4 equals negative 7. To continue to solve for x, I'm going to add 4 to each side. So what I have here is negative x equals negative 3. I want to get x by itself. We can't have a negative, so I can divide each side by negative 1. Negative 3 divided by negative 1 is going to give me x is equal to 3. So I found my x. I now need to solve for my y. So I choose one of my original equations to help me find my y. We found x, which is 3. I'm going to use the second equation. So x, 3 plus my y, we don't know my y, that's what we're solving for, equals negative 7. I can subtract 3 to each side, so my y is going to equal negative 10. So my ordered pair for this problem now is going to be, my answer, ordered pair is 3, negative 10. My last step of this is I need to make sure my 3, negative 10 is true with my two original equations. So I'm going to substitute these values into each equation to make sure they're true. Let me just erase this here. So if I look at my first equation, we have 2 times my x now is 3 plus my y, which is negative 10. Is that going to equal negative 4? Well, 2 times 3 is 6. 6 plus negative 10 gives me negative 4, so this is true. Let's look at the second one. We have x, which is 3, plus y is negative 10. Does that give me negative 7? Yes, so that is also true. So I showed all my work, I found my ordered pair, and I checked to make sure my ordered pair is true given the two equations, my original equations. Last example, very similar to the last one. Let's first solve for a variable. So let's look at my first equation. I have negative 2x plus y equals 8. I'll solve for y again, so I'll add 2x to each side. So what I have here is y equals, I'll write it in the mx plus b form, 2x plus 8. So if y equals 2x plus 8, I can now look at my second equation, my 3x plus 2y equals 9. So I have 3x plus 2 times my y. My y now is 2x plus 8 equals 9. We're going to be solving for our x's here. First, let's distribute 2 to each situation inside the parentheses. 2 times 2x gives me 4x, plus 2 times 8 is 16. So I have 3x plus 4x plus 16 on the left equals 9 on the right. Let's combine like terms on the left. So I have 7x plus 16 equals 9. I'm going to subtract 16 to each side to solve for my x. So I have 7x equals negative 7. I'm going to divide each side by 7, so I get x equals negative 1. So I found my x. My x is negative 1. So now that I found x equals negative 1, I can substitute that into one of the originals to find my y. Let's choose the first equation to find my y, given that I solved for my x. So we have negative 2 times my x we solve for is negative 1 times negative 1 plus y equals 8. Negative 2 times negative 1 is positive 2 plus y equals 8. Subtract 2 to each side. So y equals 8 minus 2 is 6. So if we solve y equals 6, my now ordered pair is negative 1 comma 6. We now need to check our work. So I can check by substituting my x and my y into the original. So I have negative 2 times my x is negative 1 plus my y is 6. Does that equal 8? Negative 2 times negative 1 is 2 plus 6. That gives me 8. That is true. My second equation, we have 3 times my x is negative 1 plus 2 times y, which is 6. So we have negative 3 plus 12. Does that give me 9? Yes, that is true. So my ordered pair, negative 1 comma 6, makes the system of equations true.